Hello everyone, and welcome to a very special Friedman Math video. It is June 12th, 2021, and this is the last video of the school year. I'll probably be making more videos in the future, but I get to take a break for a little while. So we are going to talk about the formula for the volume of a sphere. And here it is, I'm just telling you right in the beginning. The formula for the volume of a sphere is 4/3 pi r cubed. So the volume of a sphere is equal to 4/3 pi r cubed. Cubed meaning that the radius is being raised to the third power. So radius times radius times radius. Proving this would involve calculus, which is something you may learn later. Right now, we can at least make the formula seem reasonable. Let's move on to the next slide. We'll start by imagining a cube. Let's call the distance from the center of the cube to any of the walls r. Okay, so imagine that here's the center of the cube kind of floating right in the middle of the cube there. The distance from the center of the cube to one of the walls is r. Okay, we're just going to call that distance r. What is the length of each of the sides of the cube? Well, if the distance from here to here is r, and this is only from the halfway point to the wall, then the distance all the way across, which is the same as the distance from here to here, must be 2r. Okay, but if it's a cube, then the lengths of all the edges are the same. So this would also be 2r from here to here, and this would also be 2r. Okay, so all the sides of the cube have a length of 2r, where r is the distance from the center to one of the walls. All right, so moving on, if we know that the lengths of all of the sides are 2r, then what would the volume of the cube be? Well, a cube is just a special case of a rectangular prism. Okay, so we have a prism here, and the base, which I'm shading in right now, is a rectangle. How do we find the area of a rectangle? It's just the length times the width. Okay, this in fact is not just a rectangle, but this is a square. A square is just a specific kind of a rectangle. It's a rectangle where all the side lengths are the same. But anyway, to find the area of the base here, then we would just need to do 2r times 2r. So this would give us the area of the base, and then to find the volume of the cube, we would then have to multiply by the height, which is also 2r. So we have 2r times 2r times 2r. Or another way of writing that is 2r to the third power. This is just another way of writing this. Now, what is 2r to the third power? Well, we could rewrite this as this is 2 times r times 2 times r times 2 times r. We can rearrange that and get the 2's together and the r's together. So that's the same thing as 2 times 2 times 2 times r times r times r. 2 times 2 is 4 times 2 is 8. And r times r times r, we can write that as r to the third power. So we have 8 times r to the third power. So this over here represents the volume of the cube. Not the volume, we haven't even talked about a sphere yet, but this would be the volume of this cube, okay, where the length from here to here is r. Let's move on. So now let's put a sphere inside the cube, okay, and the radius of the sphere is the same as what we called r before. All right, so the radius of the sphere is from here to here, which is exactly what we said r was on the previous couple of slides, okay? So now r represents the radius of the sphere. The volume of the sphere is about half the volume of the cube, In other words, if you were to separate the sphere and the cube and pour water into them separately, the cube would hold twice as much water, approximately twice as much water as the sphere. So the sphere would hold about half as much water as the cube. So the volume of the sphere is approximately equal to half of the volume of the cube. But we learned on the last slide that the volume of the cube is 2r to the third power, or 8r cubed. All right? So let's go ahead and simplify what 1/2 times 8r cubed is, which is pretty easy. 1/2 times 8, which is like 8 divided by 2, is just 4. So this is equal to 4r cubed. All right? So we just learned that the volume of a sphere with a radius of r is approximately equal to 4 times the radius cubed. All right, now to finish, we're going to multiply that expression that we just got by 1. I hope you'll agree that whenever we multiply something by 1, the value does not change. Okay, so if we write 4r cubed times 1, that's the same thing as 4r cubed. So we're not changing the value of this, okay? But we're going to not actually write 1 here. We're going to write 1 in a sneaky way. Hopefully you'll also agree that anything divided by itself is 1. So, for example, 2 over 2 is 1, right? 3 over 3 is 1. 10 over 10 is 1. Anything divided by itself, 0 would be an exception. 0 divided by 0 is not 1. But anything divided by itself other than 0 is 1. So we can write this as we can choose any number and put it over itself. I'm going to choose 3 here. So I'm going to write 1 as 3 over 3. Okay? So hopefully you'll agree that this is equivalent to this, which is also equivalent to this. So this is equivalent to this. They both have the same value, even though we wrote it a little bit differently, so it looks different. Would you also agree that 3 over 3 is the same thing, so I'm putting the equal sign here, as pi over 3? Do you agree that 3 divided by 3 is the same thing as pi divided by 3? If you said yes, then you trust me way too much. The answer is no. Pi divided by 3 is not the same as 3 divided by 3, but pi is very close to 3. Pi, remember, is approximately 3.14. So it is very close to 3. So if we divide pi by 3, then we would get something which is very close to 1. So we could say that this expression is approximately the same as all of the others. All right? And now we can just rearrange a little bit. This expression is equivalent to 4/3 times pi times the radius cubed. All right? Which is exactly the same expression that you saw in the beginning of this video, 4/3 pi r cubed. Now that was not a proper proof, because we did have to, like over here, we said that this is approximately equal to this, and we said that this was approximately equal to this. So we were not being exact there with the proof, but if you were, maybe in high school, you'll see an actual proof for the volume of a sphere, and this is the answer that you get. So the volume of a sphere is 4/3 pi r cubed. So let's just go ahead and recap everything that we did. We said that the volume of a sphere is approximately equal to half of the volume of a cube. Volume of a cube is 2r to the third power, which is 8r cubed. This is the same thing as 4r to the third power, which is the same thing as 3 over 3 times 4r to the third power, which is approximately equal to pi over 3 times 4r to the third power. And just rearranging this, we get 4/3 pi r cubed. All right, so let's go ahead and use that formula to answer a couple of questions. What is the volume of a sphere that has a radius of 52 inches? We will write the formula for the volume of a sphere. And we're just going to plug in 52 for the radius. So now we have V is equal to 4/3 times pi. Let's use an approximation 3.14 for pi times, I made a mistake there. I forgot the exponent above the 52. Okay, now let's go ahead and evaluate this, and we'll just use a simple calculator for that. I'm going way too far. We were back on this problem. Okay, so we can do 4 times 3.14, but Mr. Friedman, you forgot the 3. I'll get to the 3. We don't have to do it right away. So 4 times 3.14 times 52 times 52 again times 52 again, because it was 52 to the third power. Now I didn't forget about the 3. Divided by 3, we get that the volume is approximately equal to 588,678, let's just round that to the nearest tenth, 0.8 inches. That would be cubic inches because we're talking about volume. All right, okay, so very good. Now let's move on to the next problem. This looks the same, but it's different. What is the radius of a sphere that has a volume of 52 cubic inches? This time, the 52 is the volume, and we're looking for the radius. But we're going to write the formula again. We're going to plug in the 52 for V this time. All right, and now we're going to solve this equation. So if we multiply both sides by 3, then that would cancel this 3 over here. So this would be 156 equals 4 times 3.14 times r to the third power. And then we have, so 156 equals 4 times 3 is 12. 4 times 14 is 56. So we're going to get 12.56 there. And then let's not forget the r to the third power. Now let's divide both sides by 12.56. Get r to the third power is equal to approximately 12.42. And now we have to take the cube root. In order to get rid of this exponent here, we would have to take the cube root. So r is not equal to 12.42. R to the third power is 12.42. So r times itself 3 times is equal to 12.42. So we have to think of a number such that when we multiply it with itself 3 times, we get 12.42. We're not going to think of that off the top of our heads. We would use a calculator for that. The simple calculator that I was using does not have a cube root button, but we could use a scientific calculator. So I went over here to desmos.com/scientific. So I can type in 12. Actually, do I type that in first or do I hit this first? I think I hit this button first. Then type in the 3 because we're taking the cube root. So we're looking for the number that we have to multiply with itself 3 times to get 12.4. Whoops. Get 12.42. Okay, and that would be about 2.3. Okay, and we can check that. So 2.3 times 2.3 times 2.3. This is not going to be exactly right because I rounded this number. But you can see we get approximately what I had in here. This would have been more accurate if I had gone out to more decimal places instead of just writing 2.3. Okay, but hopefully you get the idea there. So let's see, where were we? So the radius of the sphere would be approximately 2.3. Okay, so that's how you would solve a problem like that. I'm going to end the video there and have a great year.